Hi, everyone. Welcome. Thank you for joining. This is the Autonomous Database Learning Lounge. I'm Marcos Filanovskiy, your host. And today we have a very cool session on data lakes. So how to deliver successful data lakes with the Oracle data warehouse, right? So we're going to recording this session, and it's going to be made available to you guys later, right? So for the agenda today, we have Alexey Filanovskiy. He's a very experienced senior product manager in our team, working with data lakes for a long time. And he's going to explain to you guys, the new reality for many companies, which is trying to, improve their data capital, right? Trying to use all that data capital using data lakes. And unfortunately, there are like 85% of the data lake projects fail. So he's going to be talking to you guys about how to actually become a success story, right, with that. So he's going to be highlighting the best practices in the marketplace for taking advantage of data lakes, right? Throughout the session, we're going to have an open Q&A, so we have several product managers available to you guys. If you have any questions at any time, just ask. So we're going to have in the Q&A, so you have a Q&A in Zoom where you're going to be able to ask any questions, and we're going to be listening in and answering them. We're going to post some links in chat if when necessary, and the recording is going to be available, hopefully by the end of the week. All right. Just to make sure, these are some of the important links, right, that we have for Autonomous. I'm going to post those things in chat so you guys can easily access them. But for Autonomous Database, everything Autonomous, we have all of these kinds of things. So from, how to get a free Oracle account, to review the guide to getting started with Autonomous, to free workshops. These are free as in free beer. Yes, free. You can start an Autonomous Database free, always free account, and then use these workshops with that. And then all the other links for how to get more information, right? So announcements, LinkedIn group and things like that, right? Twitter. So I'm going to share those things in chat to you guys, okay? All right. So without further ado, thank you very much for joining us, Alexey. I'll stop sharing and I'll let you share your screen. And again, appreciate it for joining us today. Thank you.
Sure, that's a pleasure. Hey, Ron. So Marcus, thanks for introduction. Basically, as Marcus mentioned, I'm doing product management in Oracle for data lakes on Autonomous Database. So like all data lakes features for Autonomous Database on my plate. And today I'm going over to this functionality, and we'll discuss how to deal with data outside of a database with the Autonomous Database. So this is a rough plan for today, and we will just talk what Autonomous Database can do with data lakes and how it's related in general. We talk about like what data and where you can access. We can talk next we'll talk about scalability and performance. Then we will go over use cases and scenarios and success stories. And hopefully time will allow us to show, and I will show you some demos. So, but what is basically data lake or lakehouse or big data? All these terms about the same, how to analyze all data your organization has. So basically it's how to enable all data for analytics, how to enable all data to work, how to make sure that you can analyze and engage all data you have. So, and basically for this all data concept, there are two more common architecture, two most common approaches. Like first, we call it like object store centric, when like you build your data lake around object storage, you put data there, and you use like multiple engines of your choice, like whether it's Autonomous Database or Spark or some sort of open source tools to work with this data. So, and it's open, it's interoperable, because like in object store, you generally store files, and any tool that can process files is in your disposal. So, and you can pick the engine of your choice. And it's quite convenient when you do like cross-team, cross-cloud, cross-platform. So it's kind of unified standard. But on the other hand, if you don't do this, if you kind of if you kind of for Autonomous Database, it's center of your universe, why not put all data there? It's optimized and unified. And with the converge capabilities of Autonomous Database, you can do multiple things. You can do like JSON, you can do JSON operations, you can do graph, you can do special, you can do machine learning, and basically like everything is available for you. And let's focus on this architecture. It's really good, it's powerful, and it can give you like a really great performance. But what about the cost? What about the cost? And basically, you may hear that data warehouse cost is much higher than object store. It's not true anymore. So I have exciting news that we introduced a new price. So we got price reduction 75%, and now autonomous database storage costs the same as object storage. So, and you can get from 5 to 20 times faster query performance for the same cost. Basically, if storage cost was only reason and only driver to put data in object storage, it's not the case anymore. So load data in autonomous database, cost will the same, concurrency, performance, and scalability. So will be much better than on object storage. So, all right. But as I mentioned, that if cost only reason, we have to put data into the autonomous database. But there are different reasons, and we will talk about this in details later. So, for example, you may have, like data lake may be given for you, right? Have like data science team who is leveraging Spark or Notebook or any other tools, and this tool or some application just write data into the object storage, and you need to share this data across these teams. Or multi-cloud, so you may build data, you may build your infrastructure on multiple clouds, like on Oracle Cloud and anything else like Azure and Amazon, and you may have data in Azure and Amazon, and you may need to query it. And in order like how to build like object store centric lakes, we'll talk about this today. It's going to be our main focus area for today. Let's start with their understanding and with their with the discussion, like what's object storage, what is their what it is. And basically it's kind of traditional schema on read schema. Basically it means that you put whatever you put, you define metadata later on. Yes, files may have extension, but I can put a video file and rename it in CSV. Nobody will check. Nobody enforce this. So basically you have to define schema, and schema definition is kind of or part of this process of building data lake. And there are a few ways how you can define what you have inside object storage. Like if you're on the programming side, we have PL SQL API available. If you're on the UI side, we have data-friendly user UI, so like called database actions, and you can do drag and drop to define your external tables with zero coding. And also we have our support for few catalogs. So for central metadata, if you need to, on the organization level, you need to capture data. You can use data catalog. So within data catalog, you capture metadata, you define some business glossary. So you have some lineage and basically everything stored there, and you can sync data catalogs with your autonomous database. So first option, you have data into the object storage and you need to run PL SQL. Pretty simple, pretty straightforward. Just say, okay, that's my data, that's my format, create external table. On the UI end, so if you need to, if you want to create external data, database actions is in your disposal. Drag and drop interface allows you easily explore what you have and bring data with a couple of clicks of the mouse, and basically data is available to query. And the third option, like more complicated, more sophisticated, if you have data into their data dictionaries. So, and those data dictionaries allows you to enrich data, categorize data, sort data, say, okay, I trust this data, I don't trust this data, and make some links between technical metadata and business metadata. So if you need all those capabilities, and you use data catalog as a governance tool for a cloud, we can easily sync it into with our autonomous database. So basically this data catalog, you go to object storage. You may do what we call harvesting. So it means automatic metadata gathering. So imagine you have like 50 tables, 50 folders. You just say, analyze this folder. You analyze and they say, okay, it's kind of 50 tables. You do a sync. You create 50 external tables. So data remains in object storage. So you just bring metadata. And then from Autonomous Database, you can query data from object storage. If you want to learn more, I put links to the live lab. So I encourage you to try. So basically, it's pretty extensive end-to-end live lab. It goes over this use case and show how to do synchronization with OCI data catalog. I said OCI, but what if you have some data in Amazon? We are about to support Amazon Glue catalog. So it will allow you, if you, for example, do a lot of work into the Amazon cloud and you want to reuse this work with the OCI, no problem. You just connect Autonomous Database with the Glue. You soak metadata from Glue to Autonomous Database. You create a set of external tables. And then these external tables allow you to query data stored into the Amazon S3. So, and all table definitions you derive like in one sync operation from Glue. All right, and so basically here we define metadata in any convenient way, but what I would stress out that it's external tables. It means it's tables for Oracle. And it means that you can use any tool of your preference to analyze data. You like Notebook, you got it. You like BA tool, you got it. SQL developer, of course you can do it. So let's stop here, let's pause here, and let's see what we just learned and what we learn in case of Autonomous Database and data lakes. First of all, Autonomous Database, it's a native for data lake Lakehouse. It's available or out of the box. Nothing has to be installed, paged, purchased. You get the Autonomous Database and you get plenty of data lake capabilities with it. For business users, we have nice intuitive UI, so called database actions, allowing you to drag and drop and automate many operations. So. And it's Oracle. It's fully Oracle compatible. So basically, any tool you may use to with Oracle database can be expanded to the data outside of Oracle database. All right. Now let's talk about what type of data and where you can access. So access all your data. Basically, Oracle database can access data not only in Oracle Cloud. And in my previous section, I showed like Oracle, for sake of simplicity, I showed Oracle Cloud object storage, but you can access it. You can access data in other clouds, such as Amazon, Azure, or Google. And within every cloud provider, you can access like a rich set of their formats, and you can like we support like long list of the files or formats such as Parquet files, org files, CSV, JSON, Avro. So all those files are supported in all platforms. And what's coming up? It's support for Delta sharing and support for Iceberg table formats. So, and as a metadata, we just touched on this as a metadata source. You can use OCI data catalog, and Amazon Glue is coming. So, and I mentioned that you can analyze data into the Amazon cloud, and you may be curious. Okay, what about security? Can I use like a native authentication called ARN? So can I use it to sneak into the Amazon because it's maybe my company standard? And short answer, you can. And short extensive answer, you can. In addition to the traditional access secret key pair. So you may define like access secret key pair, and basically it will allow you, it will give you access to their Amazon cloud. So in addition to this, we support native. Same with Azure. Count ID password, yes, of course, we support it, but also we support Azure service principal. All right. So next exciting news, and basically it's now available. Autonomous Database can read Delta sharing protocol, table backed by Delta sharing protocol. So you might be curious, like, what is a general data sharing? It's a protocol to share data across multiple platforms, and it allows to sharing static and dynamic data. So, and basically using this protocol, you just specify your endpoint, credential, and endpoint, and say, okay, on this endpoint, my table, and data provider gives you data. So you don't specify like URL to the files, you just say, this is a URL to my data provider, and data provider over this protocol gives you access to the data. So it has like very rich ecosystem, like lots of clients are supporting this protocol, and basically another one client is Autonomous Database. But this is a part of the bigger story. So right now it's unlimited availability. Oracle Autonomous Database can be a client for data sharing, but Oracle Autonomous Database soon, now it's unlimited availability, but pretty soon, it's a matter of weeks, can be a source of a data sharing. So we'll introduce like full flavor of their data sharing support. Even more, like zoom out one layer more, like it's a part of their bigger story of the data sharing. And this bigger story include also cloud links. So this technology allows you to easily exchange data across Oracle instances. So yeah, like 2 Oracle instances, you need to share data. It's very easy to do. So, but this is it's a good topic for the dedicated presentation. So it's worth to talk like maybe, I don't know, an hour about this functionality. I just at the end of I'll just briefly touch on one of the appealing use case when you can break down data silos with a data sharing protocol with the Databricks and Autonomous Database. We heard that customer want to use Autonomous Database because it's based on the breadth for data warehousing. So also customer have some preferences for Databricks as a Spark. And basically, they run Databricks in other cloud, let's say Azure and Amazon. They have Spark on Databricks in foreign cloud. They have ADW on OCI, and both have data. And data has to be exchanged both ways. Databricks data has to come to Autonomous Database. Autonomous Database has to come to Databricks. Right now, the only way is to do it like with a data replication. Soon, it's very soon, in a matter of weeks, you can hire data sharing protocol to break down the silos and access data in place. So Autonomous Database will be able to access Databricks data into the foreign cloud using data sharing protocol. So it was a little detailed, and let me move to the next announcement. And its next announcement is an Iceberg, and Iceberg it's a table format. There are 3 table formats available and popular in open source worlds. It's a Delta Lake, it's Apache Iceberg, and some goodie. So, and now we support Iceberg. So basically, this table format, it's been engineered to manage like massive, like petabyte scale tables, and it provides abstraction layer between metadata, between physical layer between data and metadata. For example, you have like 5 Parquet files. You may say like, okay, Parquet files has schema on it. You're right. But what if you have like 5 Parquet files? Is it 5 tables? Is it 1 table? Consists of 5 files? Or it's 2 tables, like consists of two files and 3 files? What you do if schema change? How you, another one, another one question to Parquet files, how you handle updates and deletes. And basically, all those are accounted into the table formats. And in addition to this, there are very sophisticated mechanism allowing it to be like really terabyte scale. So you don't do extensive file listing. You just wrap it up in manifest files, and it speed up performance drastically, performance and latency and scalability. In addition to this, Apache Iceberg support like some sort of ACID operations. Be very careful with it, but if you need it, like once in a moon, you can do it. And these ACID operations can guarantee consistency and isolation. So, and basically Iceberg, let's put it this way, there are reasons why people use Iceberg format. What's important for you as Autonomous Database user? If someone, let's say Spark or Spark user, or like data science user, or I don't know, some other tools produce or Iceberg table, you can read it. Autonomous database will be able to read it. Autonomous database will be able to be a client for Iceberg table. All right, and what about other databases? Well, you can do database link. It's available now. And if you have data in Redshift or MySQL and you need to solve, yes, you need to sync it. And yes, you can do it using like database links. So far, we just discussed like structured and semi-structured data, but quite frequently, data lake implies that you have data in unstructured formats, such as their Word documents or PDFs. And one of the most common operations for this, it's a full text index. For example, I have 100 PDF files, and I need to know like which of these document has Word, Oracle, or Autonomous, or Alexey. And what I do, I build a full text index, and then I do full search for this full text index. And I just say, okay, something like Oracle will show me all the commands that has something like Oracle or Autonomous. And this full text index point you to the certain document saying, okay, this and that document have the word you were asking. So it's available now, and Oracle can work even with unstructured data. And you know, in addition to this, it's important to know that any of this data in any cloud can be accessed with a variety of APIs. Oracle is a polyglot system. So, and basically, if you like Python or R or PL/SQL or JSON or MongoDB API, like all those API can be hired and used on top of the data stored into their different clouds. What's unified and what's only where we don't have this kind of freedom, it's a security. So we have standard Oracle, standard and unified Oracle access control. We have column level security through views. We have row level security with VPD, virtual private database. We can hide sensitive data with data masking. We have leverage and impact analysis within database actions. So, and all these done for Oracle data along with our data outside of Oracle database. So a lot of choices, a lot of freedom, multi-platform, multi-data format, multiple file formats, structured, unstructured, semi-structured. The only unified things, it's a security. Okay, so apparently it's a good time to stop here and let's see what we just learned. So autonomous database, multi-cloud ready. So free of choice of data and table format. So we support like long list of tables and data formats, and all done under unified security umbrella. Okay, let's talk about how to process all data at scale. Of course, you maybe know that partitioning it's one of their common performance technique, and basically just chunk data into their logical pieces and then use predicates, and these predicates will just allow you to read certain read certain files. So, but it's cool. But what's really cooler and what's coming, we call it like implicit partitioning, when you define just external table. So you don't define any partition columns. You just say, this is my data. So this is like my root folder storing all my data. And then we automatically derive virtual columns corresponding to the partition keys. We do it automatically. And then you just write a query. And whenever we use predicates, we just skip part of their part of the data sets. We just read the data set we need, and we do everything automatically. So no need to maintain anything. So like all done automatically. Another thing to mention that we did a lot of investment into their Parquet file reader. So if you have like freedom of choice of your file format, Parquet would be maybe your best choice. From the performance perspective, we did a lot of investment into this, and it's written in C and leverage all benefits of the Parquet format. So also, what can help you to scale better? It's a materialized views. It's a well-known, well-established technology, but you can use it on top of data into the foreign clouds or like just outside of Oracle database. You can build a materialized view, and it will be automatically rewrite your query into their and pointing them to the small fraction of the data. So, and basically, instead of scanning whole data sets stored outside of database, you just scan small fraction of it. So, and so far we just talked about their accessing like external data from Autonomous database. But you may be curious, what about other way around? If I Spark user and I want to reach out Autonomous database, yes, you can do it. And basically, we have Spark connector for Autonomous database, and it allows you to push down the processing, and you can leverage all beauty of Autonomous database. You can leverage like all performance benefits of Autonomous database using Apache Spark. So, okay, and basically, takeaway: Oracle database can process all data and can process it at scale. Now let's talk about some use cases, and some success stories. And first use case, why you may need to deal with data outside of a database, it's access to the raw data. So for experimentation or augmenting data warehouse. So, and usually raw data stored into the original format. It doesn't make sense. Often it doesn't make sense to bring all data into the database because it's kind of garbage. So you don't use it for daily analytics. But like once a week, once a month, maybe once a year, you need to access all spectrum of the data. You need to analyze it, and you need to maybe try something new. You may try some new algorithm. You may try some new features. And basically, it's good if you have access to the raw unprocessed data. So, and data stored into the format, into the original format. Basically, you always have access to the data origin, to the origin data. Second use case, you build data into the other clouds. So you use like Amazon or Azure, and you have data there, and you have tools that provide data into the Azure and Amazon. Yes, you can leverage this data with Autonomous database, no problem. Break down silos, remove silos, and it's another use case when Autonomous database can retain in its own Oracle format. But what about Spark, Jupyter, or other set of the tools? And basically, it's a good way to store data in some central place into the object storage, and then you can leverage it using different protocol, maybe delta sharing, maybe just direct access to the files. But it's another one reason why people may store data outside of Oracle database. It's along with multi-cloud, it's multi-engine. So, and you may need to have like instant access to the data. It's another one use case for Autonomous database. So if you basically read data, you will be able to read and analyze data bypassing ETL as soon as it arrived into any object storage, either in Oracle object storage, in Amazon or Azure. So data is instantly available for you. Right, and we have few customers who tried this and who did a different type of use cases, implement different type of use cases with our Autonomous database around data lakes. So it's either self-service data warehouse platform, like in case of Outfront Media, or MindSense utilize object storage to store like really raw data and say do machine learning, and so basically they use it to access like our raw data. Or Hapvida, who basically start with the data warehousing and expanded to their external data. So, and they store raw data with object storage in multi-cloud, and they use multiple platforms. So the active Spark and Jupyter user, and this is a requirement for from Spark team that data has to be into their open format. And basically here, object store can help to fulfill this requirement. All right, and basically let's stop here. Quick recap that you can maximize your data value by making all data instantly available and discoverable. So you can maximize your productivity. So by leverage Oracle Data Lake support for existing applications and skill sets. So basically nothing to learn. And you maximize your agility by seamlessly extend your data warehouse to a data lake. So it's already there. So all capabilities out there. Before we go to the demo section, I maybe would like to go over some Q&A.
Thank you, Alexey. So yeah, we have one very good question here. Manoj is asking, hi, loading data in Autonomous Database as external tables using Parquet files is super fast. Do you have any documentation on how to tune queries on external tables, like how to create the Parquet files and other tips?
Yeah. Basically, for Parquet files, I do have a link to the blog. So, and this blog go over details about our good practices, how to build your Parquet files. Like, don't do small files, don't do big files. What is small? What is big? And basically, all those details we trying to explain this into this blog post, and also like how to inspect it. Like we give some suggestions about row groups, but how can I learn this? How can I know this? And all these are kind of best practices blog for Parquet files you can find here. And in addition to these, are just a spoiler, we working on some sort of the storage analyzer that will automate this. Basically, you will run some PL SQL and saying, okay, run PL SQL, this is a table, and it will analyze, gather some statistics like average file size, compression codec, and so on and so on. And based on this analyzer will tell that, okay, I suggest you to do this and that with your external table if you want to get more performance-wise. So it's not there yet, it's coming. So hopefully next session in a few months, I will be able to demonstrate this tool and tell about it.
Excellent. Thank you very much. I think the other questions were answered already, so I think we're ready for your demo.
Okay, great. Thanks to my colleagues to helping with the Q&A. And let's go over demo. So this demo will go over movie stream scenario. Like movie stream, it's a fiction online movie streaming company, and this I basically sell video content, and my customer base expanded rapidly, and I generate massive volume of structured, semi-structured, and structured data, and my infrastructure is kind of complex. So multiple products, different platforms. And by the way, I'm Mike. I'm data analyst. So, and I know something about IT, but I don't have a strong background. So, and movie stream doesn't have many data scientists. And in the past, we hired some to do some AI ML for us. So, and of course, I have my favorite manager, Bob. So Bob comes up with a list of genius ideas and say, oh, I need answer yesterday. Such a lovely person. A couple of words about the architecture. So we run data warehouse on Autonomous Database. Transactional system is run on Oracle on-premise system. Front-end application is backed by legacy Mongo database, and CRM run on SQL Server. So it's a full zoo. But anyway, it's given, and let's see what can I do. All right, I just came up to the office. I go to the cafeteria, grab my favorite Americano, maybe with one splash of their vanilla syrup, but no, all planned in breaking by Bob. Bob comes up and say, hey, I have all hands, and I need to find the best-selling movies, and I need it now. Okay, great. Let's see what can I do. So I know that list of the movies are stored into the MongoDB, and MongoDB, I know that MongoDB can dump JSON files. It's great, and I do that. They do it on daily basis, and I have it into the object storage into the JSON format. That's fine. And with Golden Gate, I replicate data from Oracle on-prem transactional database to the Parquet files into the object store. So into the object storage, I have Parquet files with the sales and JSON file with a list of the movies. Okay, let me execute on this. So I will have recorded demo. And by the way, it's available. And at the beginning of this presentation, I put links on this, along with other resources, such as our live lab. For example, if you want to put your hands dirty, you can do a live lab. So we have a data lake or workshop available for you. So links are in the beginning of presentation. But now you can see Autonomous Database and Autonomous Database UI. And let's see what I have into my object storage. So from first of all, I go to the object storage, and into my object storage, I found that MongoDB dumped JSON files. All right. And I also replicate data from my CRM system, not CRM, sorry, from my transactional system into the Parquet format. Okay, I have object storage, I have data, and I can also list using our Oracle API. So like from database, I can list files I have. Okay, great. And having this file, I can define external table. So let's start with our JSON. And now I'm showing like their programming way to define external tables. So I define a JSON. All right, I define a JSON document. Okay, list of the movies. Let's see. All right, it is in JSON format as a single string. Great, but I know how to work with it. It's Autonomous Database. I'm quite confident. Next step, I define my sales. All right, I define my sales, and it's partition. It's not a problem for me. I just define a pattern, and like all partitions will be recognized automatically. Okay, run the query. So run the query, pardon me. And basically, okay, I have some data. Now I need to get like top 10 selling movies. Oracle SQL on top of external data, and also I'm using like our JSON API. So with a dot notation, I specify like title, like JSON.doc.title, and it automatically will fetch our title of the movies. And I can join using this key, and I just summarize or run row number and summarize based on the price. So I run the query. Probably it's a good time to get coffee, and here just it's a good moment to remind that data are like a query outside of database will be always slower than query inside of database. You can do the best optimizations for external data, and you can do the worst de-optimizations. You can do worst de-optimizations for internal data, but internal query data you load in database will be always overperform external data. And as you can see, like this query took like 33 seconds. Oh, no, I don't like this performance. What can I do? I can create materialized view, and then like all consequent queries will be run faster. Let me do this. I create MV, I enable query rewrite. So it means that I can write data to the region table, but it will be automatically rewritten. And after this query rewrite, you will be able to get access to the aggregate, to the MV. So, but in my example, I even do it. I even run simpler query. I just create MV top 10 movies, and I just go directly with querying this. There we go, fraction of seconds. Great, I'm happy now. So I'm happy now, and Bob is happy. So great. But I was about to sneak out to grab coffee, and Bob said, listen, let's put these 10 movies on our customer-facing side. So let's say, okay, this is our best-selling movies. Let's put it on right on the front page. By the way, I know that these Mongo guys only can work with REST API. Okay, so ask is clear, front-end page, I need to put like 10 movies, and I need to use REST API to fetch this data from their database. Great. Let's see what can I do. So here, the good news that Autonomous Database is pretty well optimized for this. So it's pretty well optimized for the working as a REST provider. I go to the view, I enable view. So click here, enable. Of course, you can do it with PL SQL. For sake of simplicity, I'm using UI. So, and this view is available through the REST interface. And even more, Autonomous Database can give you an example of the REST call. I run this REST call. Great. I have some JSON. Let me format it so to make it more readable. Great. So I have some data into the JSON format. Okay, rank is kind of its number. But I need to have just 10, the most 10 popular. I put some filters. So I put some filters and I say, okay, it's less than 11, means top 10. Okay. Run query, great. And now let me beautify it a little bit. I just want to parse it and show just titles. Okay, it will be 10 titles, 10 most popular movies. That's great. That's great. Okay, so seems like exactly what my manager asked me to do. Bob likes idea, and he keep creating. So, and he said, "Listen, can we just put some fun facts about some cast, about some actors who's playing into these movies?" And he wanted to show some news feed about the actors who played his most popular films. All right. Let's see what can we do. And I know that there is some websites available, so where I can call REST API, and they will return a JSON, and this JSON will have some use or some sort of this. And from Autonomous Database, I know that from Autonomous Database I can issue a get or post call, and then analyze the output. Well, let me leverage this functionality. So I not only query like object store, I can call API. I can query API from Autonomous Database. All right. I will use like news API website. It's not an advertisement, so just a random example. So, and basically, this website allows me to put some filters, some hashtags, saying, okay, I like in their example, like I'm interested to know everything about Apple, sort by popularity, and you can specify the range. So, and they will return you JSON document. All right, seems like what I need. All right, and basically, I need to get some API key. You need to register on the platform. I need this in sake of simplicity, and I go directly to the database. And here I have a cast. So I go to my database and I need to see cast. Okay, this is a movie. This is a cast, actors who played. Of course, like multiple actors played in one movie. JSON table, powerful functionality that I will use to flatten it, right? I run their Oracle query, and it flattened me a list of the actors. And now I have it as a table format. Okay, some PL SQL coding that basically what it does, it sends a GET request to their given website, and it parses it response. So basically, it parses the response. I send a GET, and I to this website, and I get a response. All right, and using this PL SQL API, I will fast forward. I can, as an argument, I pass the actor, and I get like list of the news. So here, let me show you a simple example, like this query. Like basically, I want to learn everything about Johnny Depp. So I create like view news, and then basically I can push the filters. And I want to know all news about Johnny Depp. There we go. And basically, it's our news about Johnny Depp. Okay. Next, I will create a table. So the next step, I will create a table that will show me some results about actors. All right. And basically, so this is kind of flattened table in a format I desire, and it will show me a list of their news about the given actors. And I just say, okay, title has to be in my top 10. So around the query and say, okay, show me the all buzz, all news about the actors who played in top 10 movies. There we go. I have film title, I have actor, I have news, I have description of news. That's great. And then basically our next step, what I can do sentiment analysis. And I would be keen to show you demo, but we have only 5 minutes left. It's why I maybe stop here. So basically, I will stop here. And basically here we'll say that we can leverage API, we can leverage like Open REST API. And like part of this demo, like a next step, what I plan to do is show how to access data in Amazon. So you can from Autonomous Database run a query on top of the Amazon S3, and you can read data from Amazon S3. So I have this demo here into the slides, and also I put it into the useful links. And I encourage you scroll down to the end of the documentation and read our blog post. Have a look on the live lab. So basically, if you want to put your hands dirty, just check out this workshop. So it goes like, it has like step-by-step guidance, how to perform the steps I just showed on this lab and many more. And also we have some other interesting labs, like how you can integrate with data catalog. And also I put here like data lake OCR reference architecture. So and so useful links can be found at the very end and the very beginning of their presentation. I have also YouTube channel for the demos I just show. It's Autonomous Database PM channel. I encourage you to subscribe to track like everything we do. And we have a blog series about building data lakes on Autonomous Database, and we have live lab. So it's fresh, it's new. It's the first time I'm announcing this live lab, and I encourage you to give it a try. So put your hands dirty, try it out, and build your lake with Autonomous Database. Right. Do we have any questions? Any last minute question?
Thank you, Alexey. It was great. We have, we've been answering a few questions already. Some of them are related to the pricing you were mentioning. Some other comments about the Parquet and things like that. So guys, keep your questions coming. So Q&A is open. As we mentioned before, right? We have all these different links for you guys. But you know, we want to make sure that we are putting the content in the right places, and that you guys have access to the most immediate information about it, right? So guys, when you come back to the session, exactly in the same place you guys used to come here today, but on the main learning lounge, you're going to find the links that are on the left about the Autonomous Database, but also the next sessions. And in the session, you're going to see a little camera that's going to say the recording is available, and you're going to be able to actually download the presentation slides as well from today's session. Okay. All right. So I think that's it. I would like to thank you guys very much for your participation today. Thank you very much, Alexey. It was a great session. And all right. So next sessions, we're going to be delivering this same presentation tomorrow for EMEA, and we were going to have an upcoming presentation on data sharing. That's part of what Alexey was talking about. And then I'm going to be sending out also a survey to ask our audience for more interesting topics that they might be interested in seeing here on our session. Okay.
Yep. Thanks,
all
everyone.
right.
Thanks, Marcus.
Thank you. Thank you very much, Alexey. I will leave this running. We still have a few questions open, so I'll leave this thing running. And but in the meantime, thank you again. Thank you, Alexey. Thank you very much. And thank you guys. And I'll leave this open for a while. So if you guys have any other questions, we'll be able to answer. All right. Okay. Thank you very much.
Bye.
Have a great day. Thank you.